In today's experiment, you are going to calculate the spring constant, which is represented by a lowercase k, for multiple springs and elastics. So I'm going to go through the steps. So first of all, you need to choose at least four. So I've got a couple springs and I've got a couple of elastics here. You need to do at least four. It must be at least one spring, must have at least one elastic. And you are going to collect data for each one, at least 5 sample sets of data. And you need a picture of the elastic and or the spring so that I know which one you are calculating. You're going to record your data and upload that into a Google Sheet, and you're going to graph the data and give me your answer. And you're going to submit all this through a Google form. Okay. So how do we collect our data? Well, first of all, is we need some sort of device to help us do the measuring. So this is typically what's used for Hooke's law. It's a little post with a hook on the top where you could hook your spring on, and then you could dangle things. And then we have a ruler here, and you can pinch. Let me move that. You can pinch this and move it up and down so you can get it to where you want. Okay, that's designed specifically for Hooke's law. Me, on the other hand, I'm just a little more creative. I just took a regular old ring stand, and at the top, I put in the meter stick. So when I stand it up, it's sitting on the desk, and now I have the exact same thing. I like this one. It's a little bit bigger, and I have a little more control over what I do as opposed to the other one. So once you get this, you can then hook on, say, your elastic. And get you a little look here. So here it is. I don't know if you can see it, but there's an elastic hooked on here. You'll notice with the elastics, they don't pull tight. So I'm going to put a little tiny mass on the end just to sort of get the starting point. Okay. So what we need to do before we start is we need to do a measurement. Wow, that one's kind of nice. That one looks to be 35.0 centimeters. That's the starting point. And you need to know that number. Okay. So the length of essentially of the elastic is 35.0. Now, what I'm going to do is I'm going to hook additional weights onto it and see how far down it goes. So now I'm at about 36.4 centimeters, and I need to know how much mass. So what you're going to record, you're going to record your starting position. You're going to record, now remember, we're not going to worry about this weight. Just pretend that weight was always there. What we're going to do is we're going to add a mass to it. I need to know the mass so I can calculate the weight. Then when I put it on, it's going to move down a little further, and we're going to measure where the elastic is, not where the weight is, where the elastic, the bottom of the elastic. Okay, I record that. Maybe I record another one. See if that one breaks it. Don't break my springs. Yeah, that one's too heavy for that elastic. There we go. Once again, I know the mass. I can measure the spring or the stretch, bottom of the elastic. That's where I want to go. So remember, we're going to calculate, or we're going to measure the bottom of the elastic. Then we're going to measure a second time. When you do your calculations, it's the length that it stretched that we want, not the whole length, the length that it stretched. So it started at 35. Now it's down around 53. So it's around 18. Okay, we can do the exact same thing when we use our springs. With the spring, we don't need to have a weight on it because it should be all right on its own. So there it is. I see my spring is coming in at 39.15. Put a mass on it, see what it does. Wow, that didn't do anything. Okay. Wow, so that one's going to have a really big spring constant. I have a little drawing here of my ring stand. And I'm going to put my ruler over. And then I'm going to attach a little spring. So here's my spring here. Okay, so what we want to do next is we want to record the length of that on our ruler. So maybe that's where the spring is right now. Okay, I think I said earlier in the video it was like 4.5 centimeters. All right, and then I'm going to take a mass. Let's say I take 100 grams of mass, and I put it on the spring, and I'm going to leave that there. I'm going to draw this again. And now my spring is a little bit longer because I have 100 grams on here. So once again, I'm going to record the length. Now, don't go from the bottom of the weight because that's not, how far the spring stretched. The spring stretched to here. So now maybe this is, oops, wrong spot. Now this is maybe at 5.8 centimeters from the start. Okay. So now what we're going to do is we'll erase, I'll erase. You're going to remove that weight, and then you're going to add another one. And maybe this time it's 200 grams. We started at 4.5, and now we're down to here, whatever that is. I'll say, 7.1 centimeters from here. Okay, so that's the first thing we're going to do, and you're going to do that with 5 different masses or more. The more you do, the better your results will be. Record your length. These are your observations. Don't confuse observations with calculations and results. So then what we're going to do from here is we're going to put this into a data table and do some calculating. Before I do, I want to remind you, this is the key piece. This is X, the distance from where you started to where it is now. Okay? Some people want to use this. Some people want to use this. But it's where the spring or the elastic started, which is here, and where the spring is now, there. That is your distance X. I've taken the little data table that I had and I've put it into a Google Sheet. So let's remember what we've got going on. What we have here is we have our length of the spring at the start, and here's the length with 100 grams and the length with 200 grams and so on. Okay, so I've recorded my mass and so on. Don't forget, we need to do this for 4 different objects, springs and elastics. So you're going to have 5 different data points for each spring, and they should all be in separate data tables. Okay, these are our observations. Then what we're going to do is calculate our results. Results are in a different table. The top table are things that we observed, and the bottom one here are things that we calculated. And I calculated the X value, that was just the length, and it was simply the 5.8 subtract the 4.5, 1.3 centimeters. Likewise, over here I have the force. So the force, I took my mass and, of course, convert that to kilograms and multiply it by the force of gravity, and we get that. So nothing new there. Okay, so we have a data table, we have a result table. That shouldn't take you more than a couple minutes to create. You're going to share those with me on the Google form. Then we're going to graph it. Now, normally we would want the force. This was our independent variable, was force, and the distance it went was the dependent variable. But I've got it set up in the reverse order on purpose. So I know your math teacher wouldn't like this, but I've got the x, the distance it moved, which was dependent on the mass, coming first. And the reason is because when I set it up this way and I make my graph, you will see that the graph comes out beautiful here. And we've done graphs before, but when you graph it with the force on the y component of the Cartesian plane and the x along the horizontal, when you find the slope of your line of best fit, so that's that line right there, the slope of line of best fit in a scatter plot, the slope is your spring constant. So it's pretty simple. The slope is your spring constant.